idea for this presentation actually came from some discussions I had with Alex regarding what should we cover, but actually it's evolving over time with multiple presentations that I've seen throughout the past 6 months, and I want to incorporate some of those things into the presentation. So I'll have two a bit longer videos that I want to share with you later on, but I think it's worthwhile. I want to start by talking a little bit about what is data analytics and what do we do with data analytics, some clarifications about data analytics, and then I'll move into some of the benefits that we get from data analytics. Why is this such a buzzword? How it's related to big data? And then move into some futuristic things. What do we see in the future? Where is this going in the future? This is really the intriguing part of what I think should be. So with that, I'm going to start with a little bit of what John was talking yesterday, and just briefly, he gave a very nice introduction to the hierarchy that we all discussed, so we understand the hierarchy of data, information and knowledge, and how one derived from the other. So he gave the example, and I'm going to just browse through it quickly. The idea is that data is obviously the raw of facts, and then the information is that data in a meaningful context, and then knowledge is where we talked about some of the issues about knowledge management, knowledge capturing. We'll talk about this in a moment as well. But the idea is that we have two major buckets of knowledge areas, and some later derived more taxonomies from that. But there are two major areas. There is what we call the tacit knowledge, right? This is what my old professor Irma Vafera Fernandez from FIU, she was my knowledge management assistant professor, and she's very well known in the knowledge management area. You used to say, tacit knowledge is what you have between your ears, right? That's essentially what it is, right? And then explicit is what we can capture, what we have documented, what we can manage, what we can transfer, what we can share. And that's the idea of what knowledge management systems is about. It's about trying to capture, manage, transfer, share, etc. So what is data analytics per se? And I'll start by talking about some of the traditional data analytics, and then I'll move into what is going on in the past, I'll say 3 years with big data and how it impacts data analytics, okay? So the traditional data analytics is what was mentioned yesterday, is diving into a very large pile of data and trying to find any trends in it, trying to find if there is any relationships or trends coming up, like the discussion yesterday between diapers and beer, right? And other examples are all over. The idea of data analytics is not just finding that relationship. The idea is to create certain animations or visualizations of the data that will be meaningful for us as humans to retrieve certain knowledge. The fact that diaper is related to beer is just plain information, right? But the idea of what do we do with that, if we just dump it, then we don't use it per se. The idea is to take it to help us make decisions, right? And that's where the knowledge part that is captured from that data analytics, they're trying to visualize, for example, how this is fluctuate over time. What impacts that throughout time, or what impacts that throughout different cultures, so we can start looking at the same correlation between diapers and beers in different countries. And as a large organization, I might try to understand where are those relationships exist, what is the cause behind this. And this is just one example, but of course there are other examples as well. So the idea here with data analytics is really the visualizations, and this is why I put the logo in the corner, and I'll explain about it in a moment. The whole idea of visualizing data real time, live, is really the buzz thing, and this is why we need the big data, and I'll explain that also in a moment. There is also a move which I'll discuss later on. So this was the exploratory, the tradition of the exploratory, and then I'll explain the issue of confirmatory visualizations and that is related to it in a moment. So the idea is to take data and to go through it and dive into it and try to find within that data set certain information that from that information we can retrieve that knowledge. And so the similarity is for what we used to do in archaeology, right? And the idea is to go and what used to be is that they're building a building somewhere, right? And here you go, they find something that seems from centuries ago, and then they stop the building, right? This happens all the time in Israel. Actually, Nitz's daughter is involved with that, right? They stop the building, the construction, and they actually bring a special group, the government agency, that will start digging. Now, of course, that's a lot of cost for the building, but the findings, the stuff that they actually go through to find is amazing. Now, this is accidental. Right? The idea here is that this is accidental. It was not prepared or was assumed before that this site's supposed to have some fascinating archaeological findings. And this is what used to be with data analytics. Okay? We used to accumulate tons of data, and then once we had that tons of data, we started looking and we noticed, oh, here is a trend. Oh, here is another trend. And dig like archaeologists that are digging in a site of a building, okay, a construction site. And so there is a change, there is a shift in what we call data analytics. And this is why big data becomes such a buzz, because we're starting to use that for a certain purpose. Now, of course, it's not for the purpose of analyzing data on speeding tickets, okay, which I owe a thanks to Matt Sokola for bailing me out from the police station. But the idea is we can also analyze data for that. But the key here is to go and look into big data that we can use in a meaningful way. So what do we mean by big data? There is a discussion, what do we mean by big data? For some companies, certain amount of data means a lot to them, and they can do a lot with that. Some other companies can do more and better analytics with much smaller data. So it's really subjective. It depends on the organization itself. Okay, so this is a Wall Street Journal article recently that talks about how the growth of data over time, and of course we all have seen that, so you can see the discussion now is about Facebook being the biggest data powerhouse of the world, including a couple of hundred petabytes, and I translated this to some terabytes if you need to know. But the idea is that Facebook is going above what Google has, and there is a discussion of who has more data and what can they do with the data and the clicks that you're making and the images that you're uploading. By the way, most of you don't know, but all your images that you upload has a lot of tagging attached to it. Where it was taken, location in the world, what device was used to capture it. So there is a lot of other information that we don't even know. Most people don't even know that you're providing it to companies like Facebook and other, and they can mine that data for whatever purposes they have. Again, the key here is that there is a purpose, right? And so we'll talk about that. So this is where the shift is. The shift is to a purposeful archaeological diving into an area where we know there is something, but we want to dig more. Okay, and that's the key here. And that's the idea that is going on with the shift. So for example, I have a doctoral student who's one of the junior VPs in information systems VPs for the UN in New York. And he's working with me on a project that has a big issue for the UN. The UN is distributing a lot of food and a lot of supplies all over the world, okay? Especially for areas of disaster and areas where there is a lot of need. And so one of their biggest problem is that when they ship the information, they need to organize very massive logistics to grab that shipment and distribute it. And if it's standing somewhere for too long, if it's not coordinated well, if there are shipments going from multiple places that are not coordinated well with the logistics, with the distribution, with the housing, where they're stored, temperatures, tons of sensors and indicators that they collect data on needs to be analyzed and aggregated in order to make sure that this shipment will be distributed properly. And if they don't do it well, sometimes on the fly, some of these supplies are expired very quickly, okay? Or they're spoiled, or they're gone bad. And so one of the issues that they identify is this logistics management issue, and then they were trying to address that problem. And so for them, it's a very well-defined problem, and from that we identified, of course, the need for a certain information that we can capture: location, time, how long a certain supply stands somewhere, how long does it take to get approval to release it from customs or whatever processes, and of course the data that needs to be captured by using, and this is one of their biggest area, and this is where he's looking at right now, combination of this and the second line is the idea of looking at the information quality, the data that is captured, how it's reported in a meaningful way, and of course the APIs, all the connections of grabbing the data from multiple locations, data harvesting we call it. I'll discuss about it in a minute. The idea of aggregating the data from multiple sensors, from local governments to international organizations that supplies it into a quality information that will be valid, and of course doing all this live, because you gotta have things that needs to be analyzed right now. You need to make decisions on, should I deploy a new contract for distribution, or should I wait a little bit longer for a certain company to unload in one place and come and load in another place? And so the whole idea in here, and of course giving that decision maker the ability to make on the fly and very quick decisions. This is a very massive area for those, for the UN, for example, and it's the same thing for larger organizations that are facing almost the same situations. So I think one way of demonstrating what is data analytics in a nutshell is by showing you this short video from a company called Gapminder, and it's actually a consulting company that this professor set up, and I'll show you this. It's really emphasizing what we can do with a very simple data analytics techniques to illustrate certain trends. So let me run this quickly.
About 10 years ago, I took on the task to teach global development to Swedish undergraduate students. That was after having spent about 20 years together with African institutions studying hunger in Africa. So I was sort of expected to know a little about the world. And I started in our medical university, Karolinska Institute, an undergraduate course called Global Health. But when you get that opportunity, you get a little nervous. I thought these students coming to us actually have the highest grade you can get in Swedish college system. So I thought maybe they know everything I'm going to teach them about. So I did a pre-test when they came. And one of the questions from which I learned a lot was this one: which country has the highest child mortality of these 5 pairs? And I put them together so that in each pair of country, one has twice the child mortality of the other. And this means that it's much bigger the difference than the uncertainty of the data. I won't put you at a test here, but it's Turkey, which is highest there, Poland, Russia, Pakistan, and South Africa. And these were the results of the Swedish students. I did it so I got a confidence interval which was pretty narrow, and I got happy, of course. I 1.8 right answer out of 5 possible. That means that there was a place for a professor of international health and for my course. But one late night, when I was compiling the report, I really realized my discovery. I have shown that Swedish top students know statistically significantly less about the world than the chimpanzees. Because the chimpanzee would score half right. If I gave them 2 bananas with Sri Lanka and Turkey, they would be right half of the cases. But the students are not there. The problem for me was not ignorance, it was preconceived ideas. I did also an unethical study of the professors of the Karolinska Institute that hands out the Nobel Prize in medicine, and they are on par with the chimpanzee there. So this is where I realized that there was really a need to communicate, because the data of what's happening in the world and the child health of every country is very well aware. So we did this software which displays it like this. Every bubble here is a country. This country over here is China. This is India. The size of the bubble is the population, and on this axis here I put fertility rate. Because my students, what they said when they looked upon the world, and I asked them, what do you really think about the world? Huh? Well, I first discovered that the textbook was Tintin mainly. And they said the world is still we and them. And we is Western world, and them is third world. And what do you mean with Western world? I said, well, that's long life and small family. And third world is short life and large family. So this is what I could display here. I put fertility rate here, number of children per woman, 1, 2, 3, 4, up to about 8 children per woman. We have very good data since 1962, 1960 about, on the size of families in all countries. The error margin is narrow. Here I put life expectancy at birth, from 30 years in some countries up to about 70 years. And 1962, there was really a group of countries here that was industrialized countries, and they had small families and long lives. And these were the developing countries. They had large families and they had relatively short lives. Now what has happened since 1962? We want to see the change. Are the students right? It's still 2 types of countries? Or have these developing countries got smaller families and they live here? Or have they got longer lives and live up there? Let's see, we stop the world, and this is all the UN statistic that has been available. Here we go, can you see there? It's China, they're moving against better health, they're improving there. All the green Latin American countries, they are moving towards smaller families. The yellow ones here are the Arabic countries, and they get larger families, but longer lives, but not larger families. The Africans are the green down here, they still remain here. This is India, Indonesia is moving on pretty fast. And in the 80s here, you have Bangladesh still among the African countries there, but now Bangladesh, it's a miracle that happens in the 80s. The imams start to promote family planning, and they move up into that corner, and in 90s, we have the terrible HIV epidemic that takes down the life expectancy of the African countries, and all the rest of the world moves up into the corner where we have long lives and small family, and we have a completely new world.
So you can see essentially the idea here is to visualize the data. That's the crucial piece in here, is to capture the knowledge by visualizing the data over time. And he had a very precise, meaningful reason to dive into the data, and the way he collected certain data and the way he represented data had a reason for it, not just the traditional data analytics for general trends. And so this is where we're moving into areas like medicine and business, where we can actually capture data and we have a very precise reasons for what we're going to look for, or what we're trying to analyze. And this is where the whole area of big data can support us. And so there is this notion, and I want to discuss this for a minute, that is called the microscope. And the idea is to look at organizations from a larger view. So over the years, in the 20th century, we developed, in 1920th century, we developed the microscope, and we were able to see things that with a naked eye we could not have seen before, right? And that's the idea, that we can dive into and see cells and see things that we were not able to see before. The idea of big data has an analogy to this, but the other way around. The macroscope is the idea of looking at the whole organization, or looking at the whole processes of certain things in a larger view that we could not see ourselves from a certain area that we're at right now. So for that, MIT actually developed this project over time that was just released now in I think April of this year. And this is a report with combination with SAS that looked at 400 companies that developed analytics or using analytics or are just starting to use analytics. And they did a little bit of survey about them, and they did interviews, and they aggregated the data. And of course, given that SAS was driving here, there is a bias, but still it's interesting to see what are the benefits that companies are claiming to have as a result from data analytics. So some of it, let's start by looking at the distribution of what companies claim that they are. And so there were 3 major categories that I'm going to show in the next 2 or 3 slides about. Essentially, these 400 companies were divided into what they call the analytical innovators. These are the companies that are already doing analytics, that are already using analytics for decision making, that are improving their analytics in terms of linked to knowledge discovery and linked to decision making. Those analytically challenged are the companies that are collecting data. They have mechanisms to collect data, but they have very few uses of that data. So while they're collecting the data, it's good, it's a good step, they're still not there. And then majority, as you can see, is what they call analytical practitioners. These are companies that are in the process of collecting data. They still have data in a silo environment. They still have issues of integrating the data in order to be able to do any meaningful analytics. I have the report. If you need the link, by the way, if you need the link for the slides or you need a copy of the slides, email me and I'll be more than happy to share it. I forgot to mention this before. So one of the questions they looked into is the idea of data generated, right? And in terms of what do they use out of the data that they capture? And notice the differences between the data, the analytical innovators and analytical challenged companies. I still don't think that the analytical innovators is as good as it should be. Okay, and given that the 400 companies majority were from the US, it's still not as good as I have expected it to be. Other 2 areas that they looked into is the competitive advantage and the area of helping innovation. And obviously you can see that those who are in the area of using the analytics claim that this is significantly important for them and they're using it to a great extent. These are some projections for the future in terms of expenditures in billions of dollars on IT to capture and analyze big data. And there is some more analytics information regarding what they do and the number of professionals that were surveyed in there. We are working also on a couple of projects. I know Mitko had to leave, but I'm working with Mitko on data that we got, about 30,000 records we got from ProctorU. ProctorU, if you don't know, is a company that is doing live online proctoring for exams. And the CEO of the company is a friend of mine, and we actually got about 30,000 records of exams and some documentations from their systems. What they do is they do live online proctoring. So if you're a university, and some universities, how many universities here are using it? Anyone is using it? You aware? No? Okay. It's much more used, I guess, in the US, but there are essentially what they do is the students are scheduled to take exams, especially if they're online nursing or some other schools. I know there are a lot of, it's very popular in the nursing area where they need to do all the introductory courses for nursing online, and they do that part online, so all their exams are done through ProctorU, and they schedule, there is a scheduling system They go in, they schedule their exams, and then there is a live person looking at you while you're taking the exam. The idea is obviously the deterrence theory. We know from the theory that when someone is looking at you while you're taking the exam, the possibility you're going to cheat or be involved in unethical things goes down. And we know this thing from any Walmart you get into the US, they have rows and rows and rows of black domes on the ceiling, and maybe 10% have cameras in them, right? So the idea is that deterrence theory. So what they do is they collect data on every student that is taking exam, the time they started, the time it's scheduled, what difficulties they went through, if it was completed, what ID was provided, what type of ID. The student's supposed to show their ID and claim their name, etc., etc. So we got all this data and we're trying to find, and what their issue is that they're trying to see if there are certain schools with significantly more problems than others, and they want to see how it changed over time because they are trying to create some mitigation effects. And I'm not going to dive into more details, but essentially we got data over time, 30,000 records that we are going to analyze. Some of the issues that I'm working with Mitko is to create certain sets of instructions for the company on how to create the data properly, so next time they can actually code it to do this, whatever we're going to do live. Okay, that's the idea, is for them to actually be able to do it live. And that obviously leads to the issue of data harvesting. Data harvesting is very difficult, especially if you have multiple sources of data, because once you start collecting data from one source, it's okay, but once you start aggregating data from different areas, that becomes more complex. And so looking at, first of all, the data opportunities, where do we capture data? Nowadays, we have multiple sensors. I'm going to show you later on a couple of neat areas where we collect data from different places. Our own produce tons of data that can be used for our own purposes. The focus of the presentation is from data analytics, not necessarily from the information systems or business oriented. So I'll shift in a moment towards something that is more individual, and you're going to see that. And this is really where the trend is going with big data and data analytics. But before that, let's talk about the data capturing. I'll give you an example, a very neat example. Sometimes you don't need to have your own data. You can use secondary data. And I'll give you an example. Letonia actually had, you know that Google Analytics, Google car, the street view has been raised a lot of issues, especially in Europe, regarding going through the streets and taking pictures of the whole city, right? And some countries object that. But some countries said, let's capitalize on that. You're going to capture the data, you're going to grab the data, I'm going to use the data that you're capturing. So this is what they did, is essentially they have a very small group of people who review housing for construction tax money for the local municipals. And what they did is they started to use, instead of going and inspecting houses and go from street to street, they would sit in their AC office and they would just use Google Street View to look at pictures of the streets. And they will identify housings that they could not see from the satellite imagery on constructions that is illegal. And what happened is they started writing down all this data, and they developed certain visualizations and graphs, and then they started to create areas where they would spend time only in this neighborhood and go into all the places where they didn't pay taxes or created illegal construction. So they actually did 15-fold the amount of tax that they were able to collect from the year before by using Google Street View, okay? Which is an amazing way of using someone else's data that is freely available. And so the idea is that some companies are trying to capitalize on secondary data, and they are able to do that. So some techniques of knowledge, of this, getting the knowledge out of those that data, once we have the data and we can organize the data, and that's not an easy task, we have certain techniques that we can use to actually aggregate the data and develop knowledge out of it. But the best way to do that is by visualization. I gave you before the example of those bubbles, that this is really the simple key of looking into visualization. And so some of the areas that, by the way they did this is by using Google Motion Chart. We've done a study 2 years ago. We presented with using that Google Motion Chart. It's actually very easy. If you go into any Excel spreadsheet within Google spreadsheets, you can add the motion. If you organize your data correctly, you need to, again, this is where organizing the data, and you can animate the data free by using this Google Motion. If you're interested, come and talk to me. I'll elaborate a little bit more. There are some other tools, of course. Any statistical analysis tool is doing this. This is why SAS and SPSS and IBM is pushing. IBM is pushing very hard their products, including Cognos, which is one of their products that produce live analytics. We've seen that. Michelle and I were trained on that. The quality of the visualization is not as good as the Google Motion Chart. So, but I guess they're improving. There are places where you can grab XML and some other tools and give this to developers. This is what we're going to do with the developers from ProctorU. We're going to create this pseudocode, give it to them, and point them to this GitHub where you can grab for free the XML and the HTML coding to develop these things, which is really neat. By using XML, you can grab the data and visualize it in different ways, and they have multiple ways of visualizing the data. The data is really nice. You can, if you properly set it up, you can visualize it very nicely. You can also create this so it will produce those same charts live and changing over time. So you can see how certain bubbles are changing, certain networks are moving. The links, if you're interested in links between relationships between things, you can see how these are moving. And of course, there are more and more of these, and they're all free, which is nice. They give you the code. So just grab it and use it for your own data. All you need to do is just manipulate the coding to work for you. So that's the issue of visualization. There is a lot of work done in the open source, especially if you're in a university or in an institution where you have issues with budgets to acquire SaaS and other products. These are very expensive products. There is a lot of work that is done in the open source that you can do. Okay, so this is more of the traditional ideas. And so what will be there in 5 years? What will be in 7 years, 8 years, 10 years? And this is the idea of what I call nano-analytics. And let me explain a little bit more about this. Some people call it small big data, okay? The idea of taking big data, but from an individual. The idea of collecting data of our own data, our own, what you will see in a moment in the video I'm going to show you, the breadcrumbs that each of us will have. How many here have smartphones? Okay, almost all of you, right? So if you have smartphones, you leave tons of data, but you don't have the data. Most of the data that you leave, those traces, you don't really have. And so the idea is to try to shift and move into a way that we will get the ownership. And with that, I want to run the next video, and I'll tell you briefly a little bit about this before. This is from Tedmed, and it's actually TED Talks. Some of you are aware of those TED Talks that are very fascinating. But Tedmed was a live conference that was, I think, a month ago. And I attended the Tedmed through a live stream from our university. It cost $3,000 to get a seat in the audience in Washington, D.C. But our medical school actually streamed it to our medical dean's office, and so I went there, and there was a whole day. The conference is 3 days. There was a whole day that talked about data analytics for medical purposes. And so what I'm going to bring here is one of the videos that I think will be really, it's a futuristic. There were a couple of other presentations that discussed about 3D printers and how they're going to use 3D printers to aggregate data from multiple patients to create the ideal organs or whatever. I'm not going to get into this. This is really futuristic in the area of medicine. But in here, they talk about specifically data analytics and how it will impact our future. So with that, let's see. It's a bit longer, but I think it's worth it.
So we'll be hearing a lot about how big data, smart devices, and all the elements are going to transform medicine. And they will.
Turn it up a little bit.
But there's another trend.
Good volume.
This is the highest.
And that's small data.
Unless you have cable.
My story is about small data that's derived from our individual digital traces. It's about a picture of your personal health. It could be generated by a new kind of application running in the cloud that continuously and privately analyzes the traces that you generate as you work, play, sleep, eat, exercise, shop, and communicate. We do have special devices designed for self-tracking, like our Fitbits. I'm talking about an even wider array of data that most of us generate implicitly. We do that because we increasingly mediate, or at least accompany our lives, with mobile technologies. And as a result, we're continuously generating digital breadcrumbs in the services that we interact with. And those breadcrumbs woven together form our digital traces. You're generating those traces now, as you did when you got up this morning, perhaps checked your email or Facebook before you even got out of bed, and as you chose to maybe walk here by foot instead of getting on the tram. The service providers that we access, the search engines, the social networks, the mobile carriers, they capture and analyze that data extensively. They do that in order to improve their service, to target advertising, and to provide information. But they don't bring that data back to the person who generated them. So there's no existing vehicle that repackages the data about me in a format that's useful for me and makes it accessible to me. But there should be, because there's a lot that I can learn. Packages the data about me in a format that's useful for me and makes it accessible to me.
This is the max.
But there should be, because there's a lot that I can learn.
I think I get from here better audio. Sorry.
Now, I'm not talking about doing detailed medical diagnosis. I'm not talking about replacing the communication between you and your doctor, or with your loved ones, or even your own self-awareness. I'm talking about enhancing each of these things with personalized, data-driven insights. Insights such as early warning signs of a problem, insights such as gradual improvement in response to a treatment. Ginger.io refers to this as a check engine light. I like to think of it as a digital social pulse. A pulse because it's a single measure that I can look at over time that represents my well-being, and social because it's something that I can selectively share with a small number of friends and family. Once we, as patients, as consumers, can get access to our digital traces, to our small data, we'll be able to fuel a new market of personal apps and services. For example, your doctor might look at the output of one of these applications to help to figure out whether
So with that, the idea here is really in terms of the future, the idea is to move from what companies do as big data for their own purposes to big data that we can benefit from ourselves by using all those smart devices, by using data analytics. And this is where a majority of the innovation that is going on right now, a significant number of startups are formed to try to be innovative in those areas, especially in the medical informatics area that derived meaningful data analytics. And so the idea of an individualized big data is something that we're going to see in the future. And so one area that is already here is obviously the Nike sensors that are inside the shoes, and they measure everything about your movement and your pressure, and that will give you your own data, which can create your own information, which gives knowledge about how you're progressing, how fast you're running. You can share it, you can post it to Facebook, you can actually go and compete, and so create some competitions between individuals who is jumping higher, because it's actually measuring also your how high you jump. And so you can start using certain things. And so what Zoran was talking yesterday about the issue of the move from the industrial age to the knowledge, all the way to the information age, knowledge age. Yesterday was a discussion that talks about the idea of social networking type of age, and I'm making a claim that the next wave will be this, what we call the nano-analytics type of a wave. The idea of getting data about ourselves, about our own individual cells, that will help us in everyday life. And with that,
Well,
thank you so much.
Any questions?